So the next thing we are going to compare and contrast characteristics of are the equations. So when we're looking at linear equations, you guys recognize this is our slope-intercept form here, standard form here of linear equations, and this is our parent function. Our parent equation for a line, y equals x. Our quadratics, we've got the standard form up here. Here's the standard form. This is the vertex form. This is the factored form. And this is the parent function for a quadratic. Most students do not have any trouble telling these two apart. And the reason is because the quadratic parent function has this 2 up here. And then we throw in this form right here of an exponential. These are exponentials kind of weird because this b right here is not it's part of the equation, and this is the one I think the only case of a parent function that actually has a value that can change and still be considered a parent function. In algebra 2 we have to deal with 2 to the x, e to the x, and 10 to the x. And so the main thing that I want you to point out is all 3 of these have an x value, okay? This x value has an exponent of 1, this x value has an exponent of 2, and this x value is the exponent. Okay, so be careful and don't get these two confused. Here, the base of this exponent is the variable. The 2 is the exponent. This is your base right here. This is the exponent. On exponential functions, one of the parent functions that we'll have to look at has 2 as the base, and x is the exponent. These two are often confused. So what ends up happening is people call this the quadratic function, and they're right, but then they call this the exponential function as well because they recognize the 2 and they say, well, the 2 is an exponent, so this must be an exponential function. That's where you're wrong. What has to be true in order for you to be dealing with an exponential function is your variable, your x, has to be the exponent. X is the exponent. X is the exponent right here. X is the exponent. That's what makes an exponential equation. And before you go and try to do some sorting in your activity, let's look at a few examples. Here is an equation that has a slope of 1/2 and a y-intercept of -1, y equals mx plus b. Y equals -3x plus 2. I could give you one in standard form, 2x plus 3y equals 6. Okay, that's a standard form, but it's linear because x doesn't have, or the exponent on the x is a 1. Here we've got some quadratics. You can see the x squared. Right here you can see the square that's going to be on the x when we get that multiplied out. And here we see x times x and know that when we get that multiplied out, it'll be an x squared. So, you know, tricky things to see the x squared, but they all are there. X squared, x times x will give me x squared. Here's some examples of some of these problems right here, these parent functions that have some transformations on them. Y equals 3 times 2. The exponent right here is x minus 1. E raised to the x, and e is a number like pi. We'll talk about that as we learn about it, but that is a number raised to the exponent, and then with the transformation shifting up 5. And then here we've got a whole bunch of transformations. You got the reflection, you got the stretch, you got the shifting. So all of these though are exponential equations, and you should recognize them as such because the x Here is the exponent. You've got the exponent. You've got the exponent. The x is in the exponent.